Topic 6.6 Exponential and Logarithm Equations. So I've heard some students complain about the video qualities that I recorded previously. So this time I'm going to try it using these new apps that I found online. So hopefully it'll give you a better pictures and a better recording result. The essential questions. How do properties of exponents and logarithms help you solve equations? So we're going to continue our properties of exponents and logarithms to help us find the equations to solve for the x. So here, as I reminded you throughout our examples, our lessons, eventually we're going to solve for the x, finding the x. So we're going to look at 4 examples today. And let's go in. Depending on the situations, you have to think about log and exponentials are the same thing. So keep that in mind. First one, example number 1. I have 1/2 raised to the x plus 7 equals 4 raised to the 3x power. So now you're looking at the powers. So do not just jump in and get rid of the base. They are not the same. 1/2 and 4 are not the same. So what should I do? So whenever you deal with this type of questions, think about, can you make them into the same base as your first step? If you are able to make them into the same base, then things should be very easy and straightforward for you. 1/2. What numbers raised to will give you a 1/2? So we think about negative exponent. 2 raised to the -1 power would give you 1/2. So that's why you see from the first step, I rewrite the 1/2 into 2 raised to the -1 power. How about the 4? 4 is 2 raised to the second power. 2 raised to the second power is 4. So you can see from my first step to the second step, what did I do? I simply changed that into base 2. So the key word here is I'm trying to change them into the same base 2. Now, with a number raised to a power followed by a power, what can we do? Power of a power property. So think about power of a power properties. We multiply the exponent together. -1 times x plus 7. -1 times x plus 7, which is -x minus 7. 2 times 3x. So 2 times 3, which is 6. So 6x on the other side. So now do you see that we have the same base? So as I gave you the hint from the previous step, our goal is to make them into the same base. And the only way these two numbers equal to each other when they have the same base is they have the same exponent, meaning that -x minus 7 equals 6x. So do you see that? From this step to this step, I simply get rid of the base because they are the same base. So the only way for these two numbers equal to each other would be they have the same exponent. From here, it's the two-step solving linear equations. So I like to work with positive number, so I add x to both sides. So -x plus x, 6x plus x. So you do the same thing to both sides. Then I'm left with -7 equals 7x. Divide both sides by 7. I have x equal to -1. So x equals to -1 as our answer. So just to quickly recap this example here, I try to make them into the same base so that it's easier for me to solve. Based on same base, they have to have the same exponent to have the same value. Example number 2. 17 equals 4 raised to the x power. 17 equals 4 raised to the 4 to the x power. So it looks like I'm not able to figure this out because in your head you can think about 4 raised to the second power is 16. 4 raised to the third power, which is 64. So I don't know what that power x would be in order for 4 raised to what power equals 17. So what do I do? So I wrote you a note to the right hand side, switch to log. I cannot figure out directly. So I take the logarithm form, log 4 of 17 on both sides. log 4 or 4x. So on the second step, do you see that I try to write it and to give you the full pictures so that you see it's going to be x. Then to the left hand side, log 17 over log 4, which is using the change of base formulas. Change of base equals x, and then use your calculator. Log 17 divided by log 4 gives you 2.04. So our answer for example number 2 is going to be x equals 2.04. So do you remember I asked you this question? 4 raised to what power equals 17? If we didn't do the change of base, if we didn't change into logarithm form, we are not able to figure out a number, 2.04 power. So that's where the power of logarithm comes in. Example number 3. 3 raised to the x power plus 1 equals 5 raised to the x power. Well, can we do the same thing as example number 2? Upon first log, you may do the same thing, but as I take the logarithms, they do not have the same base, so it's going to be a more complicated examples than the previous one. So for this one, I wrote out all the steps. So hopefully you follow it step by step. As I take the log, so don't forget, I don't see a number, a base. There's no base information here. That's a base 10. Base 10. Okay? That's a base 10. So I'm taking a base 10 of 3 to the x plus 1 power. Base 10 of 5 raised to the x power. As I take the log on both sides, I bring down the exponent to be a multiplier. So I have x plus 1 times log 3 equals x times log 5. Then I distribute, so x times log 3, x times log 3, plus 1 times log 3, 1 times log 3 equals x times log 5. Then I want to put x all on one side as I subtract x log 3 to both sides. I'm left with log 3 equals x log 5 minus x log 3. So now I'm factoring out the x, so that I have log 5 minus log 3, and this is just dividing. I'm using the quotient property, log 5 minus log 3, quotient property, which is log 5 over 3. You might be questioning, how come I don't just use the calculator to do the log 5, log 3, write it as decimals? If you do your answers, do your steps early on, you're going to truncate, you're going to round up the numbers, your answer may be off. So normally I like to keep it this way and then only enter the calculators at the very last step so that I reduce the truncations, rounding issues. And then on top of that, it's really hard for me to write the decimal numbers. Decimal numbers is too lengthy to write, so I like to keep it in its form as long as possible. So to this step, you can see that log 3 equals x times log 5 over 3. Only at this step, then I'm going to enter the calculator. What's log 3? So you can put it in the calculator. It's going to be 0.477 equals x. And again, do the same thing for log 5 over 3, which is 0.2218. So do you see that? If I do this step earlier, I have to write a lot of decimal numbers. And sometimes it's going to be too crowded, and it's going to be a big hassle. If you calculate it early, you're truncating, you're rounding up, and then make your answers way off. So I normally do it the very last step. And then here, I'm dividing both sides by 0.2218. And to find the answer, x equals 2.15. So only at the very last steps, I use the calculators. I try to stay away from using the calculator early on. Example number 4. So here's an example to remind you again. ln, I don't pronounce it as ln, I pronounce it as natural log. Natural log. So please remind yourself, natural log. We are doing it natural log. Natural log of x squared minus 16 equals natural log of 6x. So can you go ahead and take out the natural log? Of course, they are the same base. Here, I would like to remind you, natural log, you can think of it as the natural log base e. But we don't really write it like this. Remember, we only going to write it as natural log. Okay, so please don't write like this. Just tell yourself in your brain. Just tell yourself that's a base e. So now we're getting rid of the natural log on both sides because the argument would have to equal to each other. The argument would have to equal to each other. X squared minus 16 equals 6x. And that is the typical quadratic equations. So how do you do to solve the x? So you have to make it into an equation equal to 0. So I'm going to subtract 6x to both sides. I have x squared minus 6x minus 16 equals 0. And then use your factoring skills. X minus 8 times x plus 2. So hopefully you still get this in your head. Like I said, this is the most critical part for Algebra 2. You should be able to do this pretty fairly quickly by now. That's the essential portion of Algebra 2. Able to factoring out the quadratic equations. We haven't solved for the x yet. This is one step before your final answers. So make sure you get some students like to call it the opposite. So x equals 8 and x equal to negative 2. X equal to 8 and x equal to negative 2. But are all both answers our answers? So here, do you remember I said that the logarithms, your argument, so the numbers for the input cannot be a negative number. So I wrote it down here. X equals negative 2 as you plug it into the natural log of 6x, you would have a negative argument. Making this not a valid input. So we have to call x equals negative 2. And extraneous solutions, you have to exclude it from your answers. So the only answer for this question is going to be x equals 8. And that's our lesson for 6.6. You can go ahead and practice on your Pearsons. Log into your Pearsons and start practicing on the examples and ask me questions you may have